Hello and welcome to another episode of Maths with Mrs. Banks, where we make maths fun and easy to learn. And in this video, we're going to focus on the second of the midpoint theorem trio, that is theorem 2 for mathematics grade 11, and that is the theorem that goes line from circle center to midpoint of chord bisect chords, which is actually just the converse of the first theorem. On that note, please don't forget to click the subscribe button and hit the notification bell so you don't miss out on part 3 and more videos we upload in the future. We have a lot to cover, so let's start. In summary, we're going to look at the converse of a theorem, what it is and how to explain it, how is it different from a theorem. Number 2, we're going to look at the step 1 of proving a theorem, which is understanding the theorem. And number 3, we're going to look at step 2, which is the goal. What is that we are required to prove. Number 4, we're going to look at step number 3 of the theorem proving process, and that is the strategy. And number 5, we're going to look at how to apply this theorem number 2 in examples or when you're proving another theorem. We have a lot to cover, so let's start. First, let's look at what a converse of a theorem is. But before we do that, let's look at what a theorem is. A theorem is basically a mathematical proposition made up of two big important parts. The first part is the statement, which tells you what you are trying to propose. And the last part, which is the second part, is the conclusion, which tells you then what you then make as a conclusion based on what the statement says. I'm going to give you an example. Here is an example. If Toto is twice Kanyisa's age, then Kanyisa is half Toto's age. This is a theorem made up of the first part, which is the statement, and the statement is it says Toto is twice Kanyisa's age. If Toto is twice Kanyisa's age, then the conclusion, Kanyisa is half Toto's age. So if the statement, which is A, then the conclusion, which is B. So if A then B, that is what we call the theorem. Now the converse of a theorem is basically switching the order of B and A around. So you start with the conclusion and end with the statement. So this is what a converse then looks like when we compare it to the first statement and conclusion on the theorem. It says if Kanyisa, which is the last part, if Kanyisa is half Toto's age, then Toto is twice Kanyisa's age. And that's what a converse is. It's the reverse of a theorem in a nutshell. Now let's look at the theorem and the converse. Remember, theorem is the theorem 1 we did in the first video. We're comparing because that is the theorem, and this theorem that we're now busy with now, theorem number 2, is actually the converse of the first theorem. How do we then compare? How do they compare? Let's take it back to theorem 1 this theorem was perpendicular line from circle center bisects chord. If a line is drawn from the center of a circle perpendicular to a chord, then it bisects the chord. So we started with the statement, if a line is drawn from the center of the circle perpendicular to the chord, it bisects the chord. So we start with a perpendicularity and we need to prove that it bisects the chord. So the conclusion is bisect the chord and the statement is perpendicular drawn from the center. In the converse, which is this theorem, we start with the conclusion in the first part, the first theorem. The conclusion which says if a line is drawn from the center of a circle to the midpoint of a chord. So we start with the bisection, right? OP bisects AB. That's what we start with. In the first one, we were proving that. But then the conclusion here, which is actually the statement of the first theorem, is then the line is perpendicular to the chord. So we start with the bisection over here, meaning AP is equals to PB. And we are required to prove that angle OPA equals to angle OPB, which is supposed to 90 degrees, meaning that OP is perpendicular to AB. So that is how the theorem compares to the converse. So this is theorem number 1 and this is theorem number 2, the one that this video is about. Now let's move on to what the video is about now. We're looking at theorem number 2, which is actually the converse of theorem number 1, which we did in the first video. But anyway, let's move on. All right, so this is not for exam. However, I did see a question in a past exam paper that required you to prove this. So rather you know how to do it than not know and have this come in an exam and not know how to prove it. So here is the converse of the theorem, which is theorem number 2. It says line from circle center to midpoint of chord is perpendicular. We just looked at it now. Now step number 1, let's define the theorem. Step number 1, the theorem. Let's understand the theorem. The theorem says if a line is drawn from the center of a circle to the midpoint of a chord, then the line is perpendicular to the chord. So let's annotate that. The midpoint is the point where a line is cut into 2 equal parts. So the midpoint means automatically that therefore AP is equals to PB. Now, if that is the case, if the line drawn from the center of the circle to the midpoint, right, it must be perpendicular to the chord. Then the line is perpendicular to the chord, meaning it must meet the chord at right angles. So meaning that therefore, what are we required to prove? Step number 2, we are required to prove that the goal is we are required to prove that angle, that OP is perpendicular to AB. In other words, angle OPA is equal to 90 degrees is equals to angle OPB. That's what we are required to prove. So now number 3, the strategy. What strategy are we going to use? All right, like with the first theorem, you already have two not right angle triangles, but we have some form of 2 triangles. The goal is to, the best strategy is to prove congruency first. And once that congruency is proven, then all other angles and sides respectively will be equal. So we can then use that to prove that this is 90 degrees. Okay, first let's prove that angle OPA is equals to angle OPB. How? By congruency. So the strategy we're going to use is congruency. And now let's choose what reason are we going to use. Okay, so we've got side, 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 angle, side, angle, angle, side, and then we've got right angle, hypotenuse, side. Now we need to choose one that's best for us. Let's eliminate. We cannot use right angle, hypotenuse, side because that's what we need to prove, that the angles are right angles. So no, we cannot use this one. We have to eliminate it from the list of strategies right now. For now, we don't have any angles that are equal given to us. So any one of these that has the angle will have to be eliminated for now. And then let's use what we can. So the one reason for congruency that is best to use for this particular one would be side, side, side. So let's go for it. All right. What will the first side be? In triangle OPA. In triangle OPA and triangle OPB. Triangle OPA and triangle OPB. OP is common. OP is equal to OP. And the reason is common side. You can write common side or simply common. Number 2, angle side PA is equal to side PB. That is given. We are given. PA equals to PB, and that is given. And now we can use the fact that OA is equals to OB. Notice the order of the letters. OA equals to OB. That is equal radii. Equals to OB equal radii. So the strategy from last time is very similar to the strategy that we're using now. Now, therefore, triangle OPA is congruent to triangle OPB. Therefore, triangle OPA is congruent to triangle OPB. And the reason is side, side, side. So now that we've managed to prove that, therefore, it means that angle OPA is equal to angle OPB. Therefore, angle OPA is equal to angle OPB. Angle OPA equals to angle OPB. Now, how do we then prove that angle OPA and angle OPB are 90 degrees? Here is what we do. We go, therefore, notice that angle OPA and angle PB, are angles in a straight line, but the sum of angle OPA plus angle OPB equals to 180 degrees. And the reason is sum of angles in a straight line, or you can just say angles on a straight line. Angles on a straight line. But because they are equal, if the sum of the two angles is, okay, therefore, because they are equal, that means angle OPA, 2 times angle OPA is equals to 180 degrees, meaning that therefore angle OPA is equal to 90 degrees. But OPA equals to OPB, therefore angle OPA equals to angle OPB, both equal to 90, each one equals to 90 degrees, meaning that therefore OP is perpendicular to AB. That's what. So that's what we were supposed to prove. That I'm so sorry about the mess, but you get the picture. All right, now that the angle is proven, let's move on to applications of the theorem. Question 9 from a past paper, it says, in the diagram, chord FD is drawn in a circle with center O and FM equals to MD. This is the theorem we just proven now. And they say, use the diagram in the attached answer sheet on the attached to complete the proof of the theorem, which states that the line drawn from the center of a circle to the midpoint of a chord there will be perpendicular to that chord. That is proof that OM is perpendicular to FD. All right, that's what we just did. Okay, let's go. Join. Let's join OF. Okay, join OF. That is the construction. Join OF and OD. Join OF and OD, and that leaves us with 2 triangles. Now in triangle OMF, and triangle OMD, yes, triangle OMD, just like we did. Okay, we prove congruency. Now OM equals to OM. That is the common side. Angle MF is equals to angle MD, given. Angle MF equals to side MF equals to side MD, and that is given. And now OF equals to OD. OF equals to OD, equal radii. OF equals to OD, equal radii. And now that this is the case, therefore triangle OMF is congruent to triangle OMD. Triangle OMF is congruent to triangle OMD. Now that we have these two, and the reason is side, side, side. Now that these two are congruent, therefore, it follows that angle OMF, therefore angle OMF equals to angle OMD. All right. But angle OMF plus angle OMD is equals to 180 degrees. But the sum of these two angles equals to 180 degrees, and this reason is angles on a straight line, they add up to angles on a straight line add up to 180 degrees. But OMF is close to angle OMD, therefore 2 times angle OMD, 2 times angle OMF, we can choose any of them, equals to 180 degrees, meaning that angle OMF equals to 90 degrees equals to angle OMD. And therefore from this we can conclude that therefore OM is perpendicular to FD. And that is how you prove that. For 5 marks, 4 marks, that wasn't easy, 4 marks. Next example, this one is from the Eastern Cape, November 2020, paper 2. And question 9 says, complete the following theorem statements. The line drawn from the center of a circle to the midpoint of a chord is perpendicular to the chord. Perpendicular to the chord. This is the theorem. Perpendicular to the chord. There we go. Next, the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. Interior opposite angle. That is how we finish this sentence. Next, in the diagram, FH is a diameter. There is FH. There is the diameter of the circle FCH. FCH. With center O. There is the center. FC is a chord. FC is a chord. And LCH is a secant. LCH is a secant. LF is a tangent. There is LF. To the circle at F, there is the point of contact F. E is a point on CH. E is a point on CH there, such that CE is equal to HE. That is the line drawn from the center of the circle to the chord, all right, to the midpoint of the chord. We know that ultimately what it says. All right, we're going to use all that information that we know. Now here is the question. The question says, prove that FC equals to, FC is parallel to, prove that FC is parallel to OE. We need to prove that this line is parallel to this line. Now, whenever we've got parallel lines, remember, parallel lines go with, parallel lines produce. Whenever you see parallel lines, remember they produce your fan X angle. That is your corresponding angles, your co-interior angles, and your alternate angles, and the vertically opposite angles, just for measure there. So whenever they talk about parallel lines, these are the angles we need to keep on the lookout. So let's look at this. What shape can we conjure up that looks similar to any of the ones that we drew there on fan? Okay, let's try and draw that shape. I see the shape of an F. Here is the shape of an F. There are the parallel lines. They form a shape of an F. So in order to prove that these two lines are parallel, basically what we need to prove is to prove that either angle O3 is equals to angle, this angle, CFH, or to prove that these two angles are equal. This angle is equal to this angle. We need to prove that this angle is equal to this angle. All right, let's go. Let's start. And that should be easy. All right, notice that angle OEH is equal to 90 degrees. Reason? Angle OEH, proof, here is the proof. Angle OEH is equals to 90 degrees. And the reason is there. This one is equals to 90 degrees. And the reason is line from center to midpoint perpendicular to chord. Line from center to midpoint. Line from center to midpoint. Perpendicular to chord. Okay, let me go back to see the reason, and it's short. Let's go back to the theorem just to make sure that you can see. Line from center to midpoint perpendicular. All right, so that's all you needed to. Line from center to midpoint perpendicular. All right, so there we go. That is a good reason. But also notice that angle FCH, all right, angle FCH is equal to 90 degrees. And the reason is it's an angle in a semicircle because FH is a diameter. So that gives us angle in semicircle. Now, therefore, FC is parallel to OE, and the reason is corresponding angles equal. Corresponding angles equal. Corresponding angles equal. That's why this is in, and that's how you do it. It's that easy. We've come to the end of this video. Thank you so much for watching. I'll see you in the next one.